Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.108. While solving this problem, we will be using delta to star configuration conversion. Here is the list of formulas which are used to convert a delta configuration into an equivalent star configuration. Now move towards the problem. Exercise problem number 2.108. Find the value of current I0 in given below figure. This is the circuit diagram of given problem. Inside this network we have to find the value of current I0 through this branch. So without wasting time, let's proceed towards the solution. First of all, if we observe these three resistances are connected into delta configuration, so in order to solve this problem, we have to convert this delta configuration into star configuration. For that purpose, we will place a star connection inside this delta configuration. Equivalent resistances in star connection are marked as RA, RB and RC, and delta connection resistances are labeled as R1, R2 and R3. We will use these three equations to convert this delta connection into its equivalent star connection. Start calculating RA. For that purpose, we will take the product of R1 and R2 and divide with the sum of three resistances R1, R2 and R3. Solve this equation to calculate the value of RA, that will be 4 ohm. Now all of these resistances connected in delta configuration have same values. So their equivalent resistances in star configuration will also have same values of 4 ohm. We have found the values of all resistances in star configuration, so we can replace this delta connection with star configuration. Now these two resistances and these two resistances are converted into series connection, so we will find their equivalent resistances for further simplification of the network. R equivalent of these two resistances will be the sum of both resistances, that will be 12 ohm. Similarly, R equivalent of these two resistances will be 18 ohm. Now we will replace these series connections with their equivalent resistances. In order to calculate current through this branch, first we should have total supplied current. If we know the value of total supplied current coming on this node, we will apply current divider rule to calculate current through this branch. But before that, we have to find total supplied current through this network. For that purpose, we will find the equivalent resistance of these two resistances, that will be equal to the product of both resistances divided by their sum. So R equivalent will be equal to 7.2 ohm. And this R equivalent of these two resistances will be in series with this 4 ohm resistance. So the total resistance of the network will be equal to the sum of 7.2 ohm and 4 ohm. So R equivalent of complete network will be 11.2 ohm. After getting the value of R equivalent of complete network, we can calculate total supplied current using Ohm's law. Current through this network will be equal to 24 volt divided by 11.2 ohm. So the value of current will be 2.142 ampere. And the direction of current will be counterclockwise, leaving from positive terminal and entering towards negative terminal. This same current will be entering on this node. Modify the network by indicating current with its direction. Now at this stage we can apply current divider rule to calculate current through this branch. For that purpose, we will use this equation to calculate current I0. In this case, R1 will be 12 ohm and R2 will be 18 ohm. And I total is total supplied current, that is 2.142 ampere. So place values inside this equation. 18 ohm divided by 12 ohm plus 18 ohm multiplied by total supplied current 2.142 ampere. Solve this equation to calculate the value of current I0, that will become 1.285 ampere. So the value of current I0 through this branch is 1.285 ampere. So this was exercise problem number 2.108. Thank you. See you again in next video.